Welcome back to Summarize Science. Today we are looking at a breakthrough in how AI models handle complex problems. Large language models usually have to think out loud by typing out every step of a math problem before giving you the final answer. While this works, it is slow and inefficient because the AI spends a lot of energy making its thoughts look like human language. Researchers have developed a new method called reasoning in memory, or RIM, to give AI its own internal workspace. Instead of typing out every step, they introduce special memory blocks that the AI uses to crunch data silently. These memory blocks are made of special tokens that act like a digital scratchpad for the model to use. Because these blocks are fixed and do not need to be typed out one by one, the AI can process them all at once. This makes the reasoning process much faster than the old chain of thought method, which was the previous standard. To teach the AI how to use this new brain power, the researchers used a clever two-stage training curriculum. In the first stage, they made the model show its work after each memory block to ensure it was actually thinking properly. In the second stage, they removed those training wheels and let the AI refine its answer silently across the memory blocks. A custom attention mask was used to make sure the AI stayed focused on the problem and its own internal memory. They found that the AI actually gets more accurate as it moves through more memory blocks. This proves that the AI isn't just guessing, it is using that internal space to systematically improve its conclusion. When testing this on difficult math benchmarks, the new method matched or even beat the performance of models that think out loud. More importantly, it was much faster, showing a significant lead in processing speed over older techniques. In some cases, the model reached the same answer 27 times faster than models that have to type out their thoughts. The researchers also checked if the AI's internal thoughts were actually organized and meaningful rather than just random numbers. By mapping out the data representations, they saw that the AI was creating a structured workspace unique to each question. This shows that the AI is learning to manage its own working memory, much like a human would when solving a puzzle. This development is a huge step toward making AI more efficient and capable of deeper reasoning without wasting computational resources. To recap, the researchers found that AI doesn't need to speak to think, it just needs a dedicated place to store its ideas. They achieved this by using memory blocks and a training method that forces the AI to ground its thoughts internally. This could mean a future where AI is not just a chatbot, but a lightning-fast logic engine. It could lead to assistants that can handle massive logic puzzles in the blink of an eye without making you wait. It marks a shift from models that simply mimic human speech to models that have their own internal way of solving problems. This research opens the door for even more complex reasoning models that could eventually outpace human speed and logic. We may soon see AI that can solve scientific problems in real time by thinking through millions of scenarios in its silent memory. Thanks for joining us on Summarize Science to explore this fascinating leap in AI technology.